Next up, we're going to try a live broadcast from deepest Gloucestershire, and really pleased to welcome Steve, who is a hobbyist coder and electronics expert, and he often interacts with us in the Raspberry Pi jams that we hold up here at the Malvern Hills. So we're delighted to welcome Steve, and he's going to tell us a little bit about the Raspberry Pi and how you can control things with it.
Hello everybody, I hope you can see me. I'm set up here in my garden office to show you a little bit about what's going on. Trying to just get my zoom thing right. Right, I'm going to switch the camera, I hope. Right, Raspberry Pi computer was brought out in February 2012. It's gone through several iterations since, and the latest is the Raspberry Pi 4, and this is on there, a Raspberry Pi 4. You see it's a computer. It has a 40-pin interface here. There's also a much smaller cousin, the Raspberry Pi Zero, which is a very powerful little computer. You can see one here, and again, it's got the 40-pin interface. The 40-pin interface is known as the GPIO header, and on it there are 28 programmable pins. And the other pins are used for things like the voltages, 5 volts, 3.3 volts, and the ground. And there are several of each of those. Now, whenever I talk about the GPIO, the first thing I say is not all pins are equal. Some pins have specific uses. Some pins have hardware features that can be enabled. For instance, there's a I2C interface, an SPI interface, PWM interfaces, and these have hardware assist that can be used. And so when you pick your pin, it's quite important to have a little think. But if we take our simplest input, a pin can be high or low. Just going to start something here. I've developed a box for interfacing to the Raspberry Pi. And this box I call a SensiPi. All it does is take the 40-pin header, brings it out to a box where it gets broken out, and then I can connect various sensors. So here we've got one with a light level, and we've got humidity, temperature, atmospheric pressure, just a straight breadboard, some buttons and some LEDs, some just LEDs. So a variety of interfaces that let us use it. Over here, I've got a real SensiPi running on a Raspberry Pi 2. It's one of the older Raspberry Pis before the Raspberry Pis had Wi-Fi as standard. So there's a little Wi-Fi dongle. There's a USB connection, HDMI connection to the monitor, and the power input. So there's a Raspberry Pi. Here's the SensiPi. Connected to this SensiPi, I've got a weather station windspeed monitor and a rainfall gauge. This is a weather station rainfall gauge. Rain falls in the top, comes out at the bottom having been measured. This is a cutaway of the rainfall gauge running with a pump pumping some water up to the top, and you can see what's going on inside. And there's two little buckets that fill and tip. Now, if I get back to my computer, which is running, if you have a look at the rainfall monitor, I've lost my zoom picture completely. There we go. The rainfall monitor, you see it's counting the number of tips and the amount of rain over intervals. The wind speed, if I generate a bit of wind, is doing very similar into into its interface. So there we've got rainfall and wind speed. Now, how does this relate to the GPIO? Well, these are very simple interfaces. They may look complicated. Let me measure. Here I've got a program running in the Thonny IDE. It's a very simple program. Whenever a button is high, it's saying button high. If I then press the button, it says button low. Now, a button circuit, or a low voltage signal. The GPIO pin, set as an input, can read either high or low. So here I've got a circuit that is normally held high. I press the button and it pulls it low, and my output changes on the screen. So take my finger off the button and it goes back high. So what is the similarity between an ordinary button and my wind speed monitor? If I unplug the button from the pin it's on the Sensor Pi and move the wind speed pin over, plug it in. Right. If I now look at the input on the screen again, if I get my finger off the thing, I've got button high. Start turning the thing, button high, button low. So all that's in the wind speed meter is a magnet and a magnetic reed switch. And the reed switch is being used to do it. So all my wind speed program is doing is counting the number of revolutions, in other words, the number of times the button is pressed over a time period. And I can use that for the wind speed. Now, it's very similar. I'm going to unplug this noisy thing for the rainfall meter. If I take my wind speed out and move the rainfall over on the Sensor Pi, looking at the rainfall meter, I'll use my fingers here because it actually clicks too fast to do it. Button high, when I get to the middle, button low. So I've shown all my rainfall meter is a very simple button. So there we are, two simple button circuits that are being used for some quite complex measurements. And by the way, for anybody who's worried, the goldfish aren't real. Keeping on. There's another very simple use for this simple high-low circuit that I've come up with. My father-in-law lives by himself up in Gisborough, and he's 95. So it would be quite nice to have a bit of just peace of mind information that he's okay in the morning. So we took a simple infrared motion sensor, and all this does is when it sees motion, it provides an input that's set high, and when not, it's low. And every 5 minutes, we count the number of times we've seen movement. We send this to a network app called ThingSpeak, and ThingSpeak can produce some nice graphs. Here is a Raspberry Pi set up with the motion sensor, a button. No. So this is in the books. Here we have a quick graph. This is today's live data. You can see he not went to bed, but stopped using his kitchen because that's where we've got the box set up at about 7 o'clock last night. And then got up revoltingly early, sometime just before 6 o'clock this morning. And that's when he first went into the kitchen. Now, all that does is provide us peace of mind. I also get stats out. I get the Wi-Fi stats and things as to when I see errors, and we have detected broadband errors before he has. Anyway, there's some simple input. Thank you very much. Over to Adrian.
Thank you, Steve. That was fantastic. For all those budding hobbyists, you can have a go at putting some of those things together.